everyone, and thank you for joining. My name is Anna David, and I'm a content manager within the Kaizen Digital Insights team. In today's webinar, we will be hearing from a highly esteemed guest, Professor Chee-Onn Leong. Professor Leong has extensive experience in genomics and has received several prestigious awards, including the Fund for Medical Discovery Fellowship in the US, the Institute of Biomedical Science President's Award in the UK, and the top Research Scientist Malaysia. He was previously a senior research fellow at Harvard Medical School and Massachusetts General Hospital in Boston. Professor Leong is currently a fellow of the Institute of Biomedical Science, the Royal Society of Biology, and the Royal Society of Chemistry, all in the UK. He also served as a professor of genomics and deputy director of research at the International Medical University in Malaysia. He holds the position of adjunct professor and visiting fellow at the Broad Institute of Harvard and MIT, and is the founder and CEO of AGTC Genomics, a technology company that specializes in advanced genomics technology. Today, Professor Leong will discuss the initial challenges and ultimate triumphs they faced in adopting comprehensive cancer genome profiling and liquid biopsy in Southeast Asia. Please welcome Professor Leong.
All right, thank you. Thank you for having me here today. So I'm glad to share some of the experience and also the hurdle and also the challenges that we have overcome over the years when we try to implement precision medicine in Southeast Asia. Now, I think today, this is my disclosure. So as mentioned, I'm the CEO of AGTC Genomics, which is a private lab based in Malaysia currently. And this is the legal disclaimer from Kaizen. Okay, so today, I think if we talk about precision medicine, I think most of us would agree that precision medicine do save life, basically. So, but however, at the same time, when we talk about precision medicine, most of the time, it is also giving the impression that it is actually expensive. So, and when it comes to Southeast Asia and also some of the countries that is of low and middle income, so some of it might not be able to afford this type of high technology diagnostic testing. Now, so why is it precision medicine is expensive that many people have think of? I think it comes down to two major factors. One of it is that, it requires a high capex, a capital expenditure to set up the state-of-the-art genomics lab. So, and the second important part that actually can cost the expensive of the how expensive the test is mainly because of the high OPEX. Now, I think because of this, so a lot of the time when we saw a lot of the tests that are being implemented with more developed country, when it comes to the implementation in the low and middle income countries, so it becoming a big hurdle. So we see that the take-up rate, for example, 10 years ago, the take-up rate for precision medicine and also genomic testing have been very, very low in this region. And I think only until recent years, this trend have changed quite significantly, mainly due to the reduced cost of the sequencing, for example. Now, I think just a little bit background and also the demographic data for the audience who are not familiar with Southeast Asia region. So now, if we look at the population growth currently, so I think Asia have always been the most dense in terms of population. So Asia have the highest population with all the continental combined, basically, and it is growing at a tremendous rate as well. So for example, by 2050, it is expected that Asia would have at least 5.3 billion people in Asia. And where is Southeast Asia? Southeast Asia is basically here. So at this region here, which consists of a few countries, including like Thailand, Malaysia, Singapore, Indonesia, Philippines, Vietnam, Myanmar, and so forth. This is where the Southeast Asia region is. Now, if we look at the income for these countries, basically, some of the countries are actually in the high income region. For example, Singapore, Hong Kong, Japan, and South Korea, and even Brunei, for example, based on the gross national income. They are actually considered a high income country, but the majority of it are either at the lower middle or actually at the low middle income group. So when we talk about diagnosis, basically, so a lot of the time in this part of the world that most of the tests are still limited to blood tumor marker tests, for example, okay, like CEA, CA135, and so forth. So precision medicine have not commonly been practiced in some of these countries. And not to mention also is that besides the diagnosis, there is also the treatment needs as well. So for example, a lot of the time when the genomic tests have pointed out some of the targeted therapy that would be beneficial, but actually not all the targeted therapy are widely available in this part of the world as well. So there are some challenges that we need to meet, for example. Now, if you look at Southeast Asia region, for example, okay, if you look at some of the countries, so maybe I just point to this column here, okay, the out-of-pocket expenses for each individual based on country, you will see that a lot of the time, most of the time, in fact, that the healthcare expenditure are mainly out-of-pocket spending. So, for example, Myanmar, Philippines, Vietnam, so more than 44 or 50% of the expenditure is actually out-of-pocket expenses from the patients. Only certain countries, for example, Thailand, they are well covered by public sponsored healthcare, but the rest of it are mainly out-of-pocket expenses. So in Southeast Asia, basically, what we are facing now, the main challenge is actually the healthcare costs and also the rapid population growth as well. Southeast Asia have recorded one of the rapid population growth in the region. And of course, some of these countries are also rapidly going to become aging society as well. And at the same time, we have to combat with the low income, which is still struggling in most of the part in this region. So when you combine all these challenges together, and put that into precision medicine context, we have seen a lot of good things about precision medicine, but it is only as good as it can be implemented to the patients. If we cannot implement this to the patient, so no matter how good the technology is, it won't benefit the patients. And that have been the major challenges that we are trying to solve here. So the main challenge that actually amplified during the COVID-19 pandemic time. So during that time, many countries have locked down, basically, and Malaysia is no exception. It was during that time then we suddenly realized that how much that our healthcare is actually dependent on the service provider or the services that's provided by other countries. So for example, during the COVID-19 pandemic lockdown, a lot of the samples, the tissue samples, the tumor tissue samples, was not able to send out of the country and send to the lab overseas to actually do the test. So you will be quite surprised, even in Malaysia, a lot of these tests are actually being sent to countries like UK, US, or even Singapore to do the testing. But unfortunately, during the lockdown, so this was not happening. So it actually causes a lot of the patients was being stranded in the sense that their samples cannot be analyzed, and they end up have to choose the treatment that is based on conventional treatment, for example. So that have been the major challenge, and that is also where the wake-up call is. So we realize that, okay, as a country, and I think in many places as well, so we do need to have some capacity to actually provide the precision medicine, no matter how advanced or how simple it is, it needs to have this type of facilities and this type of capabilities to deliver it to the patients to help them when they are needed. So and that is where we came in. So The question is basically how we can actually make precision medicine accessible and also affordable. So as I mentioned before, so precision medicine there have been a lot of evidence to suggest how beneficial and the clinical utility it is. But when we really implement it, so we really have to think about the healthcare disparity and how we can actually make this technology really accessible and affordable to the majority of the populations. So this has been our purpose, basically. And what we did is that I think immediately after the COVID-19 pandemic, so we decided to venture out. I used to be working in the university, so then but then we saw this need, so then we decided to venture out and set up the first private genomics lab in Malaysia. So we actually brought in and also installed the first Illumina NovaSeq and also the Dragon systems in Malaysia. And recently, we also obtained the first ISO 15189 certification for whole genome sequencing. And currently, we are one of the labs that are offering the comprehensive gene profiling, as well as the circulating tumor DNA liquid biopsy in Malaysia. And currently, we also is one of the labs that have sequenced more than 1,000 whole genome in a single year. So these are some of the things that we have set up. So, but what is more important is that, what make the genomics and also precision medicine a reality even for us is mainly because of the sequencing costs have come down quite significantly. So imagine, I think if it is just 5 years or 10 years ago, so we wouldn't be able to afford to sequence the whole genome, or even for tumor biopsy, it will still cost a lot of money to actually sequence it to get the right treatment. So that is not very feasible. But because of the cost of sequencing have gone down quite significantly, so that is no longer a big issue in sequencing the tissue or for treatment and also diagnostic purposes. So, and because of that, I think currently there are actually more and more sequences that are coming out. So we have people that actually come and is totally healthy and are curious about their DNA. So they just want to sequence, to find out what kind of disease that they might have, or a lot of it are actually doing carrier screening as well. So never before that we have actually experienced quite a huge surge in terms of demand in terms of DNA sequencing. So previously, when we do a lot of all this DNA sequencing, so the interpretation is not so much of a challenge when the volume is very small. But now with the increased volume of samples and the interpretation and also the analysis becoming a big challenge for us. So like any of you would have familiar with the workflow and the process of DNA sequencing. In this case here, for example, doing the sample isolation, targeted enrichment, library prep, and also NGS sequencing, this part, all the way to here that there's no issues. Basically, there are a lot of reagents and also kits that could actually support that. I think QIAGEN also have a very extensive range of reagents that actually support different type of diseases, different type of cancers as well. So when it comes to NGS sequencing part, currently we have the NovaSeq. We also have the MiSeq cater for a small panel, PacBio, Nanopore, and also 10x Genomics as well. So for research purposes. So our lab basically running NGS for diagnostic as well as some of it for clinical research. So running the NGS is not an issue. Running the DNA analysis, the primary analysis is also not of an issue because we also have the in-house Dragon to do the primary analysis, and sometimes we also use the QIAGEN's CLC to do the secondary and tertiary analysis as well. Now, so all in all, it's good. So we are actually well covered to run all this assay until all the way to data analysis. But the biggest challenge when we decided to switch from a research lab into a clinical diagnostic lab is about the interpretation part. So when we get all the data out, so the question is that how are we going to interpret this data that would be meaningful for clinical decision support? In the old days, a lot of this can be done manually. I think even until today, there are some labs that are actually doing manual curation. As I mentioned before, it is possible if the volume is actually not very high, but unfortunately, so now I think because the sequencing have come down quite significantly, so the volume do increase, and we also need to have a interpretation system that is actually following international guideline. And all in all, so the interpretation of the data for clinical use become one of the major challenge that we face. So if you look at that, as I mentioned again and again, the genome cost has come down. So if you compare now, so if we do the interpretation manually, so it will become costing even more expensive compared to the sequencing. You will be quite surprised, for example, okay, we used to outsource some of the interpretation and analysis to third party, but the cost is actually extremely high. So, and that is why we make a decision that, okay, we wanted to set up the in-house expertise and also set up the in-house capability that we can actually do our own interpretation. So then what we do is basically now we have a lot of the data and each patient's data is coming to us, and we need to make sense of all this data in order for the doctors to make the decision. So we've gone through many different ways, okay, so which I won't elaborate too detail here, but eventually what we are looking for is basically a platform that could actually allow us to actually do this clinical interpretation in the most seamless way, and that is something that we are looking for. So these are some of the key considerations when we come to choosing what kind of clinical interpretation software for our own setting for our NGS lab, basically. So this is not exhaustive. This list is basically not exhaustive. Basically, these are some of the things that, well, we put it up, and then we actually have to think about when we decide, okay, what kind of platform and how are we going to do about it, whether we want to use an existing platform or do we want to invest to develop this platform, which will be extremely expensive, I believe. So, but nevertheless, so this list here just to share with you, okay, some of the thought process that we have gone through when we want to implement the clinical NGS. Now, for example, okay, when it comes to application, so on day one, we are very clear that our lab is going to be able to focus on germline as well as somatic variants determination as well. So because as I mentioned before, we do have a lot of clients or a lot of patients that are interested to do carrier screening, which is germline, but we also cover a big group of patients, cancer patients, which we need to do the somatic analysis as well. So in terms of application, so we are quite clear that we need a platform that could cater for both the germline and also the somatic variants determination. Now, it is also very important because for healthcare, especially I think in Malaysia, so we follow a lot of the systems that are established, basically. In fact, healthcare in general sometimes can be a little bit, it's because it is regulated. So it is important to have some use case that we can showcase to the authority that, well, look, so this is the platform or this is the methods that we use, and it has been used by other major healthcare facilities as well. And to do that, so we need to find a platform that have been tested and have been used in major healthcare. So, and that is important for us. So, and also the platform need to be comply with clinical guidelines. So there are so many clinical guidelines now. So for germline, for example, it needs to be comply with ACMG guideline. For somatic, okay, we need to comply with ESCO, AMP, CAP, and so forth. So, and this is very important because the reporting that we are going to do, so it's not only just for Malaysia alone. So we are actually, well, it is important also that the test is also being recognized for the results is also being recognized, okay, in countries around the region or probably even beyond this region into North America or even Middle East or other part of the Asia as well. So that part is important. Also on the applications part, okay, we also need to make sure that the user interface and usability is important. I still remember 10 years ago when we do a lot of the bioinformatics, so we still have to do the coding and then we still have to do the mining of the database manually and so forth. Now, I think it is important for us that the application need to be user interface. The user interface need to be very, very friendly because, well, we have we need to have a group of people that could actually use this platform, okay, day in, day out, and not just limited to only a few specialists. So I think the user interface is very important. Now, when it comes to consideration for the hardware and the licensing part, I think this one is even more important because it involves the cost and also the pricing part. If we choose the wrong type of platform or the wrong type of format, so then your price, okay, might go skyrocket and people might not be able to afford it as simple as that. So we were spending a lot of time to decide whether we want to want to consider for cloud-based or do we want to invest into the on-premises solutions. Okay, cloud versus on-premise, there are both of it have its own pro and cons. So for example, in healthcare, so a lot of the time probably the data would be preferred to be on-prem because afraid of the data breach, for example. But on-prem solutions most of the time also involve a higher capex and also maintenance as well. So, and in time when the data grow bigger and bigger, you do have to provide the physical space for this on-prem premises as well. And maintaining it is not going to be cheap either. So this is some of the challenge that we have to decide. Cloud-based, on the other hand, basically it can be quite flexible, it can be quite scalable, but it doesn't mean that it is the most cost effective either. So we have to balance this both. So this is important to make sure that the cost that we actually incur would be the minimal so that more people can actually afford this type of test. And when it comes to licensing, it's also very important for us to consider whether it is going to be a single license, whether every user need to have a license, or whether it could be just a single institutional license and have multiple users. So this will actually affect our operations a lot, and not to mention it will definitely affect our operation costs significantly, for example. Now, when it comes to data management, so we were also very clear is that, well, we need to make sure that the data integration and also the compatibility is there. So in the future, if let's say we want to integrate this data into some of the lab information system or even the health information system, it can be done. Now, it need to comply to the regulatory, for example, HIPAA or GDPR for privacy. Okay. And one of the things that I think is also becoming quite important is about the clinical trial databases. So the clinical data, well, the clinical trial database is important for us because Malaysia also have a major initiative to drive, okay, to attract clinical trial into the country. And having this database integrated into the system have two major important factors for us. One of it is that, well, we can actually attract more clinical trials and help to recruit the patients to the right clinical trials. But at the same time, it also help our patients basically because sometimes, okay, the treatment could be so expensive. And if there is a clinical trial that is available and that is suitable for some terminally ill patients, I think it could serve as a good option for the patients to decide to enroll into this trial. So I think having this clinical trial database is important. And even more important is that I think a lot of the clinical trial in Malaysia are currently registered under the clinicaltrial.gov. So when we identify certain patients or certain mutations from the tumors of these patients which are eligible, we will normally alert the patients and also the doctors so that they can actually look into possibility of participating into the clinical trial. So, and for data management also is that because as a private lab and we are just a small team, and to support the whole data structures and also the data infrastructure is utmost important. And I don't think we will be able to do it on our end. So because well, as you see later on, is that it involves so many different databases. So if the platform that could provide us with an ongoing support and also updates periodically, I think that would be great, because the field, the oncology field, and also the drug that is being approved have changing all the time, basically, and all these updates will be very, very meaningful to us. Now, when it comes to clinical reporting, I think it would be good to have it will actually be really, really good if it can support the multilingual reporting. So I think most of the reporting currently are mainly cater for well, it's mainly available in English, but we do have clients from different countries. For example, okay, they want to have a different language so that their doctors and also their patients will be able to understand the report as well. This is something that that would be great in the future. I think it is important, especially for Southeast Asia, which is quite diverse. Some different country might speak a slightly different language. So this is this is something I think we can work on it and to improve on that as well. And also for clinical reporting, okay, there are also we are also looking for something that could actually allow us to customize the report. So different doctors, different hospitals, they do have a different preference. For example, okay, whether they want to report the allele frequency on the summary page, or whether they want to find it, you know, in the variance information page. So some of these details, okay, would help, because again, well, based on the preference of the doctors, so it is important to get their approval so that when they order this test, they would be able to make use of the report fully. So, and for clinical reporting, I think it is also important, for example, for us to actually allow the flexibility to actually include and set up new tests. So we do set up new tests and also new panels from time to time to cater for different needs, different hospital or different market segment, for example. Okay, so not just everything comprehensive gene profiling, because some of the hospital or some of the patients, okay, they might not be able to afford, or they might not want to have a comprehensive profile. They might want to have just a small panel, and we do that as well. And the platform that we are looking for should be able to cater that kind of customization and not just fixed to, for example, I think some of the platform is basically you can only do the interpretation if you buy the kit from the same manufacturer or from the same supplier, for example. So in those type of setting, I think it will be quite difficult for us, because we do customize quite a lot of the panels as well. And finally, I think all in all this, okay, it has a lot to do with the financial part as well. So both on the science part, the science and the knowledge-based part, it need to be robust, but it is also important for us to actually balance out the financial part, okay, to make sure that the system are actually cost-effective, and to make sure that even more important is that it is scalable, so that we don't actually have to put upfront a lot of the capex, so we can actually pay as we go, and we can actually grow together when we grow to a bigger scale, so then we can actually afford the better things, for example, and not to invest too much into it, because there are still a lot of uncertainty in this field, in this market, for example. So this is something that's very important, okay, for financial consideration. So what we came across then is we have been searching and looking for a lot of different platforms. And I'm glad that, well, I think the team managed and also decided to go with the QIAGEN Clinical Insight Interpret, or the QCI, or QCII in short, we call it, from QIAGEN. So I will share with you, okay, some thought process, okay, why we actually decide to use the QCI versus other different platform, okay, in a short while. A lot of it is to do with what some of those factors that I mentioned just now. So, and one of the most important thing is that when we tested so many platforms, so we also run the acceptance test. Basically, we want to make sure that the results that we generated, the doctors are going to use it. I think that is the most important part. So there are some report generating platforms that are so complicated. The report look, well, very complicated, and the doctors might not be able to comprehend it, or the doctors have to sit in a specialized training course to actually implement it. I think that would be some challenges there. So from day one, we want to make sure that the report that's generated is insightful enough for the doctors to actually make a good action. So what I will show you here, for example, is that now for the QIAGEN, for the QCI or the for the QCI, one thing that strikes us is basically how rich the QIAGEN knowledge base is. So we used to do data mining from CleanWar, from one database to another database. But when we come to QIAGEN, the QCI, basically it has integrated all this data into it. So that is the good part about it. Right, so we don't actually have to mine it from one database to another database, or we don't have to write our own code to actually extract all this data out. So and this is something that, well, strike us, and this is something that we like about the QCI platform. And what is more important is that so it actually updated quite frequently. So every now and then it will be refreshed, and all this data would be refreshed. I think that is something that is very good, because honestly speaking, we simply will not have the resources to do the update as often as we like if we are going to do it in-house. But with the QCI, I think that solved one of the biggest challenge that we have, which is actually the updating part. So on top of that, not only that the knowledge base is so rich, but it also have a different layers of interpretation and also analysis that actually help and guide you to the final interpretation. So this is very important, because when you look at the platform, it is actually explainable. So explainability is very important, because sometimes, okay, certain variants that came out, it is named as pathogenic. So the doctors might want to know how was this actually being decided, and how do we make the call. And we are able to trace back step by step, looking back into the criteria based on the ACMG guideline. So to actually explain how this decision was being made. So I think this is very important. And not to mention is that I think a lot of the time, most of the lab will probably just use CleanWar to actually report the pathogenic or the non-pathogenic variant. But using the ACMG guideline, they have more criteria compared to just looking at CleanWar alone. So, and to actually implement the ACMG guideline, if we want to do it in-house, it will need a lot of resources, okay, to actually curate. But with the QCII, that I'm glad that they actually have this automated, and they have this criteria set. And the moment that you input the VCF file, then it will actually generate this outcome based on the ACMG guideline, and we can actually trace back, okay, what criteria and what is the decision and the call that is being made. I think that is very important. Having a rich having a rich knowledge base is important. So by having that knowledge base to be able to make the interpretation, and then from the interpretation can trace back step by step how the interpretation is being done and can be explained. That is another added advantage. And I think these two parts combined together make QCII a very, very robust platform to actually use for clinical reporting. So just to show you, okay, this is for a somatic report example, so generated from QCII. So it has the we can make the TMB call, the microsatellite status, and also some of the mutations. And the good thing about it is that it straight away, okay, list down the recommended approved treatments, okay, based on the mutations that's being detected. And when we talk to the doctor, so some of the doctors' feedback is that some of the drugs probably that they have even not heard of, or sometimes they might, maybe they don't have time to actually follow up what is the latest or the approved treatment. So sometimes, okay, some of these drugs, okay, that was newly approved actually appear here, and the doctors are actually quite excited to find it as well. So I think the important thing is that it lists out the list of approved treatments so that the doctors can actually make a decision. It doesn't tell you, okay, which treatment you should give to the doctors, but rather it gives you the options. I think when the patients see it, it's also good because then they can see what are the options that they can choose. Obviously, when it comes to deciding the final treatment, whether they are going to use which drugs, not okay, besides the effectiveness of the drugs, and a lot also depends on the cost as well. So in Malaysia, for example, okay, some of the drugs, I mean, we have two healthcare system, public health and public healthcare, which is actually sponsored by the government, and we also have the private healthcare, which is mainly out-of-pocket spending, for example. So these two types of healthcare, basically, the choice of the drugs that is available are very different. For example, in the public healthcare system, so not many, I mean, not all the targeted therapy are actually available. So that's why those patients that are undergoing the public healthcare system, so based on the report, then they can actually choose the drugs that are actually available there, right? So if it is not there, then they can then go to the private healthcare to actually get the treatment. So all this give a very, very good options for the patients and to the doctors to make a decision. So and this is very important because the ultimate decision of what treatment to get, we have to understand is that part of it is science, the other part of it are probably non-science. So these are something to do with whether the patients are ready or to accept the side effects, and whether they can afford it, and how long they can afford it. I think all this need to take into consideration. So with the list that is actually provided here, it does help to create the engaging discussion between the doctors and also the patients to make the right choice for them. The right choice being is that the best in terms of medication, but it's also the best in terms of the affordability, how much they can afford and how long they can sustain the treatment journey. I think this is very important. So of course, the rest of the report is also give a very, very rich information about the different genes and the treatments and so forth, with all the clinical guidelines, following the clinical guidelines and recommendation, and also the clinical literature as well. If the doctors want to look up further, so they can, based on the synopsis here, to understand a little bit more about the effect of the drugs and so forth in the scientific literature. So now I think so that is how QCII looks. Okay, so now in the last part of the talk, so maybe I will just try to run you through, okay, the thought behind why we eventually, okay, decided to go with the QCI. So as I mentioned before, we have compared with a lot of other solutions out there. But at the time when we decided that time, so I think QCI give a distinct advantage. So for example, okay, as I mentioned before, our clients or our patients basically are looking for germline and also somatic mutations. So we need a platform that could handle both of it. And QCII, basically, they can handle these two very, very well. So it's a two slightly different algorithm, but under the same platform, same login, basically. And once you're familiar with the platform, there is almost, no difference when you navigate the interface between the germline or the somatic variants analysis. So that is a good thing. So now, whereas I think some of the other platform that's available out there, most of the time they can only handle one type of data. So what we do not want is basically to have one platform which is handling somatic, and then we also have to have another platform which is handling germline, right? So I think sometimes and most of the time is that some of the platform that is out there can handle either just one of those data, so but never the both. Okay. So when it comes to the use case in major healthcare, I think we also asked around. Basically, I think the QCI have been run in many hospital settings, including some of the hospital in NHS, for example. Okay, whereas some other platform are mainly run in the US healthcare system and also elsewhere. So in Malaysia, because we are a Commonwealth country, so we actually follow quite closely the UK system. So I think that's a plus point there. But either way, I think having this type of use case, and it's good that QCI have been used in many places, so that we can actually showcase how this system have been used and have been tested. It is not a totally new system, so which can be quite scary to implement while in any of the healthcare if it is too new. But in this case here, it does have a good source of use cases that we can actually use. Now, when it comes to compliance with clinicals, I think this is an absolute minimum. Whichever platform it is, it needs to comply with the clinical guidelines, and QCI definitely did, and so does other platform as well. Now, when it comes to user interface and also the usability and also the friendliness, so the good thing that we like about the QCII is that, well, most of us that have, most of the staff or most of us that we have not dealt with clinical interpretation, for example, okay, we'll find it quite intimidated when we need to look at documents after documents and go through a few days of training, okay, and some of it even requires some coding, for example, okay. But then with QCII, I think the interface is make it so user friendly. Basically, it's almost like it's almost like browsing the web, basically. So it's so interactive that you can actually find information by just 2 or 3 clicks away. Basically, you can find all the information that is needed. So, and that is very important. So compared to a lot of the platform, which is too complicated and too technical. So there are so many technical terms that you probably need to even look into the glossary to understand it. But when it comes to QCII, I think the user friendliness is there. Basically, I think everything is set quite nicely, so you can actually use it almost straight away or gone through just a minimum kind of training, then you would be able to use it. I think that is the beauty of it. And when it's come to hardware licensing and also data management, one of the advantage that QCII give is basically it is one of the earliest mover when into the cloud-based solutions. So we do come across some of the platform that, well, we have to purchase and then we have to set it up in-house, either in our server or in using a workstation. So the challenge is that, so if you are managing a lab that have multiple different locations, you have to multiply all this on-prem resources, it will be quite costly. So when we decided QCII, then so they are one of the earliest mover in adopting the cloud-based, and we are glad that while it is cloud-based as well, so that many people, okay, from different locations can actually access it. And more important is that, well, we can even access it remotely at home, you know, when the results when the sequencing just completed and the results just out, we want to give the first-hand results to our doctors. So sometimes we do wake up in the middle of the night and do this analysis and deliver it. So we are glad that we can actually do it over the cloud at home. So don't have to come to the office or the lab to actually run the analysis. So this is a plus point. Now, when it comes to licensing, okay, we have been looking for something that is a single license, okay, institutional license, and that could allow multiple users to use it. And I think QCII allowed that, which is very, very good. And not many platforms will actually offer that. I think a lot of the time, most of the platforms out there are offering mainly single license per machine. Depends on how many machines that you want to install the software in, then you have to pay for those licenses. Okay, for QCII, basically, I think it is a single license, and basically we can set up multiple users so that more people, our different pathologists, our hematologists, our pathologists and our genetic pathologists can actually access to it quite seamlessly. Now, as I mentioned, integration with the clinical trial database. So I think this is good. So most of the platform currently, I think, would have integrated this, and I think QIAGEN have also integrated this as well. And we were able to actually identify some clinical trials in Malaysia, which the patients eventually managed to enroll. I think that's a good news about it. And of course, the ongoing support. So now the ongoing support is very important because a lot of the platform, because it is a software platform, you will be quite surprised how important it is having a physical support team that is located near you is actually quite important. So a lot of the time we thought that while we might think that, you know, since this is a software, we can actually have virtual or remote support team. It actually doesn't quite work that well to us, honestly speaking. So for us, I'm glad that because in Malaysia, QIAGEN do have a support team locally here. So whenever we come into some problems, so we are just one phone call away, or sometimes they might even come over here, you know, if we need additional training and so forth. I think having that local presence, having that physical presence is very important. So it is not like just you subscribe to a software, then you know, if you have anything, you just have to call to their call center. I think that model doesn't quite work for us. So and for us, the physical presence do give us the advantage, and also do have the do help us quite a lot. And finally, I think come to the clinical reporting and also the financial consideration, right? So as I mentioned, it would be great to have multilingual reporting. I know that could be a lot to ask, basically, but currently I don't think QCII has it yet. So does other platform as well. So I think some of the major language, for example, okay, like Chinese and English, and in our part, of course, we also need the Malay language as well. So sometimes some of this, okay, sometimes we do have to engage our own medical translator to do the translation if it is needed. So, but otherwise, I think most of the platform are mainly English at the moment. I hope that in the future, there will be some multilingual reporting features coming up. Customization, yes, QCI allowed a customization of the report to a certain level, but it's a little bit limited. So, whereas some of the other platform, they have some of it, one of it that I have seen is quite fancy. You can actually do the widget. You can drag and drop, you know, like what kind of graph or what kind of info or table that you wanted to present in a different format that you want. It's almost like setting up a template using PowerPoint, for example. Okay, basically, but in the software you can drag and drop all these widgets. That's pretty cool. Actually, I think that's quite good. But I think for QCII currently it's a little bit limited there. So hopefully in the future it will have that ability as well. So extensibility to new tests and panels, definitely. I think QCII is one of the platforms that are quite flexible enough. We can actually build our pipeline, or we can actually build our gene panels that we wanted. So, and then the analysis will then based on the same knowledge base, the same rich knowledge base to actually make the call. So with that, we can actually come up with different type of validated custom panel, for example. I think that's important. Compare, as I mentioned before, some of the platform are only designed for the kit that they actually supply. So those are the ones that probably are not going to be very useful. And of course, when it comes to cost-wise, scalable is important. The current arrangement with QCII is mainly pay per analysis. So we don't have to pay setup. We don't have to incur a lot of the capex there. So basically, when there is an analysis that need to be done, then we would be just paying based on that. Because you would imagine there are so many different type of analysis, right? Whole exome, whole genome, even somatic mutations. There are so many different panel size. So you will be quite daunting, right? To actually to manage all these different well, imagine that if you need to set each of these pipeline up and then they charge differently. So, but with QCII, I think the pay per analysis is something that is very good. It allows us to actually manage the cost quite well, and also allow us to save a lot of the CapEx cost, which we then translate and transfer back to the patients, okay, with a lower price of testing costs. So I think finally, okay, I think moving forward, I think the future of genomics when it come to clinical setting is going to be very broad. So we now have the capacity to actually, running a single gene sequencing all the way to hotspot, small panel to large panel, and even the whole genome sequencing. It depends on what are the approach that is needed. I mean, it depends on the needs. I think it's good to have all these tools and all this capability and capacity line up. So whenever it's needed, then we can deploy it. And the good thing about it is that whether we are doing single gene, hotspot, large panels, or even whole genome or whole exome, so now we have one single data interpretation platform. And we are all using the same platform for all the different type of analysis regarding whether it's germline and somatic. And all this data would then be located in the same place. So, and when we want to look at certain statistic, for example, certain germline variant in the population, for example, it is just as simple as clicking a few buttons, then we can actually get all this statistic out. I think that is important to have a single source of data instead of having different platform that you need to navigate it's differently. So I think this is something that we are quite happy with. So as I mentioned, moving into the future, we will be venture into many different type of tests, okay, including even pharmacogenomic testing, for example, rare diseases, newborn screening, generation health, okay, for newborn, for population studies. So these are something that is in the pipeline. So for rare diseases, definitely, and even for cancer, so that there are so many areas that we are still working on to cover it. For example, okay, including like liquid biopsy. So we are already offering it, but there are also other cancers which is relatively rare. For example, sarcomas and also leukemia, which need quite a large panel because the mutational spectrum is actually quite diverse. So these are something that we are working on. But all in all, so the good news is that now with this single platform, okay, regardless of, as I mentioned, whether we do a large panel or a small targeted panel for certain type of cancers, we can actually analyze the same way. So, and to certain extent, it also allow us to do, for example, when it comes to affordability, we can even start to do a small panel first, which cater for the most common drugs that is available in Malaysia, for example. So if we couldn't find any actionable mutations there, then we can actually expand the analysis into broader and all the way to comprehensive gene profiling. So that is now feasible because we are using now the single interpretation platform compared to previously when we are using multiple or even doing it manually. So I think that comes to the end of my talk, basically. So I'm glad that I'm able to share some of the experience that we have. So this is my contact. So if you have any questions or that, feel free to contact me as well. And with that, so I will stop here and thank you for listening.
All right. Thank you for that wonderful and highly informative presentation, Professor. It seems that we have a bit of time for a question or two. So first we have here, of all the considerations that you brought up earlier, which would you say are the factors that need to be prioritized by someone who wants to start a clinical genomics lab?
Wow. Okay. Very, very good questions. Yes. Well, I'm summarizing a lot of all these factors, but I'm glad that you asked me this question because the one most critical one that is, overruled all is basically the acceptance. No matter how good your system, your knowledge base is, your report, I think the most important thing at the end of the day is that, well, we need to make sure that the doctors are able to use this technology and is able to use this information to make a good clinical decision. And that will be the main factor. So it doesn't matter how great the technology you have, but if it is too sophisticated and the analysis take too long, too expensive, it's not going to work. And I think with this, while with the QCI, I think it strike a very balanced point in the sense is that the moment when we present some of the demo report to the doctors, so straight away that they can make sense of what it is, okay, and they straight away then they can actually make the decision and straight away that they can appreciate, how simple it could be for precision medicine, basically, because we have already done all the back end work. So now when it comes to the front end, we want to make sure all this hard work is not lost, so that all these insights will now be transferred to our doctors so that they can make the right decision for the patients. Yeah.
All right, thank you for that. And another question that we have is, in your opinion, what is the most challenging hurdle that you've had to face in adopting these advanced technologies?
Right. I think for us, especially in Malaysia, I think in a lot of the Southeast Asia country, the first thing is about the cost of the test, right? So I think a lot of the time, patients and even doctors are not prescribing the test because it is deemed quite too expensive, basically. Now, but that is a hurdle that I think all of us need to overcome. So well, sequencing costs come down quite significantly, which is a good sign. So we do hope that like the data analysis and also the data cost can come down in the future as well. So, but we do not know. It seems like the data is getting bigger and bigger. So you need more and more computing power to actually generate the insights. But this is something that we hope that it will also come down eventually in the future. So if you ask me what is the biggest hurdles and the challenges, I would say that it is still very much down to the dollar and cent, which is the cost of actually running this test and also providing it to the patients. But the good news about it is that I think with all the support, the interpretation, the sequencing, and all this. We do see a trend, and we are also glad that now we can actually bring down the cost quite substantially, so that I think a lot of people would be able to afford this, especially for cancer patients. It is so important for them to get the right treatment at the first attempt. I think that is most important. And previously they might not be able to afford it. It can cost, like many months of their salary. Now probably they will cost just only half months of their salary. So which is becoming more and more affordable now. Mm-hmm.
All right. Thank you again, Professor, for answering those questions. I'm afraid that's all the time we have today. Thank you for sending in your questions, and please feel free to send us any other questions that you may have. We will address them after the webinar as best as we can. Thank you again, Professor Leong, for sharing your knowledge and time with us. And thank you to all the attendees. I hope you learned a lot from this as I did. Have a nice day and see you on our next webinar. Bye.